Yeah, hello everybody, dear colleagues, dear guests. It's a great pleasure for me to welcome you on behalf of Graz University of Technology and ESEIA to the 9th lecture of the ESEIA Lecture Series, Sustainable Energy Innovation Systems for Climate Neutrality. The topic of this evening is advanced tools for planning and management of climate neutral buildings. And this topic is of course of utmost importance, as the climate targets can only be achieved if we succeed in decarbonizing the building sector. Action must therefore be taken, and action is being taken. For example, by the EU, by employing the EU taxonomy for sustainable activities, which was implemented as part of the European Green Deal initiatives. On top of that, the rapid technological developments in the field of digitalization offer new opportunities and solutions for decarbonizing the building sector. So the topic of this evening is very relevant and also very interesting, and this interested is reflected also in tonight's audience. I don't know actually how many participants we have already now in the audience, but at least from what I got from ESEIA, we should have participants from different countries, from 15 different countries, including 9 European countries and 6 African countries, and also representatives from a lot of different organizations, including business organizations and higher education institutions and research organizations. So in particular, I would like to welcome some guests, and I hope that I do not miss anybody. But first of all, I would like to welcome colleagues from the ESEIA members, for example, Michael Bongartz from the TH Cologne, or Fabio Montanino from the Cyprus Institute, João Cardoso from the National Laboratory of Energy and Geology, and from ESEIA partners from the African Union, I would like to welcome Abdoulaye Ballot from ECREEE. I hope I pronounced your names correctly. If not, please accept my sincere apologies. Last but not least, I would like to thank Brigitte Hasewend and the ESEIA team for organizing this wonderful lecture series. And most importantly, many thanks to Dr. Carlos Ochoa for giving tonight's lecture, to Dr. Steffen Robbi and Professor Salvatore Carlucci for responding to the lecture, and to Professor Alexander Bassa for chairing this event. Thank you very much. I'm very curious and look forward to an interesting evening.
Thank you very much, Michael, for hosting us so well at TU Graz, because this is TU Graz services that we're using here, both online and on site. Thanks very much for this introduction. I would also say a few words from the ESEIA about the lecture series. As was mentioned, this is the 9th event in the lecture series. And why did we come up with this lecture series? Is because we wanted some friendly and scientifically informed dialogue about energy solutions that could help us become climate neutral in future. And so we are inviting a series of renowned European experts and also internationally to share their views. And we also want invite people from the civil society to give their opinions, and sometimes their opposing opinions, and we have a very good debate. So I look forward to this debate, and I would like to thank also not only TU Graz for providing the setting for this lecture series, and to our honorary president of ESEIA, Harald Kainz, for thinking up this lecture series, but also to the ESEIA team, especially Dr. Hannah Lee, who organized the event so well. So thank you very much to Hannah. And without further ado, I would like to pass on to Alexander Prasser, who is the chair of the evening. Please, Alexander.
Yeah, hello, a very warm welcome also from my side. It's an honor also to chair the session of today with a very important topic. As I think most of you know, we have a lot of upcoming legislation in Europe. Michael was so kind and already mentioned some, but also in this frame, this is a super important topic. We have also an upcoming revision of the European Energy Performance of Building Directives or new recast of the construction products regulations, and all of these policy instruments support climate neutrality in the frame of EU climate laws. So even more, it's also important to welcome our speakers, and as it was already introduced, we have 3 speakers today. Our first speaker is Dr. Carlos Ochoa. He's an architect with specialization on sustainable and environmental design analyst, and he joined the IERC as Building Energy Senior Researcher. His research primarily also focuses on balancing energy savings with user quality, in addition to his experience in sustainable design of climate adaptable buildings using both passive and active technologies. Our second speaker is Steffen Robbi. He's the CEO of Findet Stadt. It's a innovation laboratory on digitalization and planning of cities, a platform for the construction and real estate industry. Previously, Steffen was also a business manager and senior engineer at the Austrian Institute of Technology, where he was responsible also for the area of building digital technologies. Our third speaker is Dr. Salvatore Carlucci, professor at the Cyprus Institute. He is a tenured full professor at the Energy, Environment and Water Research Center. He is also the head of the Sustainable Built Environment Group. He received a PhD degree with honor from Politecnico di Milano, and he is also a subtask leader in IEA EBC Annex 79 on occupant-centric building design and operation. So also a very warm greeting, because you are kind of a colleague from me, as I'm the operating agent of Annex 89. A very warm welcome also to you. And having said that, I would then also like to go back to the program. And there we have the lectures. Brigitte, can you let me know?
Yeah, we will move to the next slide. And I think, no, sorry, it's not our slide. We'll have to swap the slides, I guess.
Exactly.
And Carlos is showing his, yes.
Okay, Carlos, the screen and the audience is yours.
Yes, thank you so much. Thank you, Alexander. And thank you also for our audience here tonight for taking time to listen to us. And we hope that you will find it rewarding. Just let me share my screen. Can you see it as a presentation?
Yes.
Yes, we can see.
Yeah, so a little bit more publicity for IERC. It's part of Tyndall National Institute, which is the ESEIA member. And Tyndall is the largest research center in Ireland, and we are also part of University College Cork. We deal with research that has to do with decarbonization, with the acceptance of energy policies. And in my field, it's about energy and buildings, thermal comfort, etc. So this evening, I've been asked to talk about advanced tools for planning and management of climate neutral buildings. And the lecture outline is the following. There will be first a short introduction, then an outline of the current tools for planning and management of the buildings, then followed by the state of the art in the advanced tools for planning and management in order to meet the climate targets. and then we'll go with some conclusions. So as an introduction, first of all, why do we need to complicate our lives with climate neutral building planning and management? First of all, the people in the buildings rather than the buildings themselves, they use energy, and not all of it comes from a clean source. This means not all of it comes from renewables. So there are the issues from climate change brought by man-made activities, the issues of rising emissions, health, and at the same time, we also need to pay for this energy. So it's better if we can reduce our consumption. At the same time, there are increased requirements for climate reporting. This means how people, organizations, industries are reducing their emissions. And it has become not only just a goodwill gesture, but it's a legally binding commitment for companies and also for the countries, especially in the EU. There are national laws that are obliging to do this, and also European Union laws and directives that are obliging the member states to comply with the reporting in order to see if the climate targets are being met. As Alexander mentioned, a new directive called the EU Taxonomy defines what is a sustainable business on the basis of several aspects. Also, any company cannot just come and say we are green, because they also have to prove it. And this is because there have been many claims by organizations and companies regarding that they have green credentials, but it wasn't the case. So there is now anti-greenwashing legislation. This means that any claims must be backed by evidence. Therefore, it is important for building managers to know how much their buildings are using in terms of energy and the corresponding emissions. So what I'm going to talk about is about tools that can help achieve climate neutrality for building design, for building automation, and for building and facilities management. The most interesting way to achieve it is when the three aspects are related in real time or are the input of one to the other. For example, like going from building design to automation, and then from building facilities management, then going as a backward loop to inform how the building was doing, and then try to plan for new buildings that will consume even less energy and have less emissions. For this talk, I will concentrate on building design and building and facilities management. The building automation is not the scope of this talk and can be dealt separately. For example, tools for the design of the climate neutral buildings. What are they? They are programs that help us in create, modify, and optimize a building design. They also automate several tasks that are related to the drafting and to assigning the information that is placed in the design of this, which is contained as a digital format. Also, it automates the creation of documentation that can help us carry out this design. So the important is to find the relationship between information and documentation, because it will help us keep track of the climate emissions. The tools for the building and facilities management, they are also software programs that help to keep track of the different assets in the building. For example, the type of lighting, if they are going to be replaced or not. Also, it helps to automate maintenance schedules and follow up on different requests. For example, if every 3 months a certain component needs to be changed. Also, if people are saying that their lights are blowing off, or if they are too cold, too hot, etc. And then this is kept in a log. Also, it helps to automate the building operation and use. For example, like every day, the building opens at 8 a.m. and then you need to have a certain level of lights and facilities open. This also can be automated. And as these activities take a financial aspect, they can also be linked to an accountancy. So there has to be a relationship between these elements that are here highlighted in order to have a coherent management of the building. Then going to the next aspect, the current tools for the planning and management of the buildings. There is no uniform way to work across disciplines involved. This means from design to the management, to the day-to-day operation, to even the accountancy. And sometimes the same tools that were used for the building creation are used for the building management, which is, as we're going to see, is not an ideal situation. For example, tools for planning. This can be CAD programs, the usual that most of us might know. Then BIM, Building Information Management. This is a more recent development in terms that you can assign the information to the symbol used. However, if you want to do an environmental analysis, this is usually considered as an extra module, and we're going to see later. So it's not that you have a CAD program and you expect to have a green building from the start. If you are only using the current tools, then it depends on the knowledge of the designer, the engineering team, in order to provide an energy efficient building. Tools for the building management, they are diverse and they are not usually connected. They include manual and electronic complaint logs, what I was mentioning earlier. Let's say people complain in the building that is too cold, they could put a request to the facilities manager, and then he will try to answer it. But it might or might not be kept stored, or you might or might not do an analysis. Then you have manual and electronic inventories of the assets in the building. This means, for example, you have a small barcode, and then people go from place to place, laser scanning, and then checking that you have all the items in the building. Or, for example, that the same barcode is used to ensure that there was some maintenance done to a certain element. Then, as I was mentioning, the maintenance scheduler that reminds the facility manager when they have to do certain tasks. For example, checking HVAC systems, checking heating systems, or procuring certain elements. Then, as mentioned, we have CAD, the BIM, the building management system as a scheduler, for example, turning on and off lights at a certain time. Also, and this is more widespread now, the building energy dashboards. This means that a certain vendor sells you the software, sells you the sensors, and then you start seeing what goes on with the building. However, you don't get a feedback like what to do with this information. You only see, okay, my building is overheating, my building is having a lot of energy expenditure, but it might only tell you where it's going, but it's not the action that you could do. And of course, accounting software, if you want to keep track of the expenses, for example, how many light bulbs were used in a certain period, the expenses to repair equipment, to repair furniture, etc. However, more than often, the facility managers use software packages that are not connected to accomplish other goals, including the environmental reporting. So this makes it also very difficult because you don't know what is the actual emissions from this, the actual energy efficiency. So you have to go and almost sit down and make a calculation separately. The tools for environmental reporting are usually used by life cycle analysis consultants. For example, one-click LCA, because this is a time-consuming activity. The consultant might go to the facility or the portfolio of buildings. They might take an inventory, for example, an energy audit, everything that is in there, maybe ask about the processes. But then the value that is recorded is usually static because it's what was made during that time, and use a generalized assumption. For example, this process is using a certain amount of emissions, but we don't know if the process was because of the time when the audit was carried out, or if it can be changed. So this also poses a certain challenge. Also, can be said that mainstream design tools lack an analysis and presentation of the outcomes of several scenarios. For example, what happens if I change the size of the windows? What happens if I change the volume? Also, there is no interaction with other tools, mainly because of vendor issues and compatibility. Also, there is no real-time interaction with the occupants in terms of monitoring their well-being and taking any corrective actions. And this also means that, for example, if people are hot, they depend on, or cold, and they depend on the capabilities of the actual system and sometimes the goodwill of the facility manager to see if this can be changed. And this creates conflicts in terms of people not being satisfied, like the famous sick building syndrome, etc. And this affects productivity and, of course, also the value of the building. At the same time, as I mentioned just a few seconds ago, life cycle analysis might be too static and also just offers you the picture of that moment. Then it can be said that also one of the factors that sometimes is not taken into account is that the adoption of newer tools, as we're going to see soon, depends sometimes on the work culture. And you can see these funny stickers that sometimes they depend, okay, no, I'm the one that knows everything, so everything has to be done as I say. Or again, like they cannot think that it's a good solution because that is the way that we do it here. And at the same time, also the company that is managing the building, which can be the owner or can be a facility manager, they have a certain approach to investments. So they might say, okay, we have to invest on a certain software, but this takes the initial front cost, the training, and the follow-up. And then depends on the actual profits that they make for this, which sometimes it can be very...
I don't see the slides. I don't know what's wrong.
Sorry?
The slides is not visible in my screen.
We can all see it, so there's a local problem. Can you check?
Okay.
Please continue.
Yes, thank you. Then the good news is that, as it has been mentioned earlier, there are new directives, there are new laws that commit companies and also countries to have an increased legal reporting of sustainability. So this will create a demand for more tools and the adoption by businesses. So we hope that these pictures that you see here will change eventually and become substituted with a more streamlined climate and target reporting. So now let's go to the advanced tools for the planning and the management of the buildings and how to meet the climate targets. The new tools need to include environmental planning and reporting from the earliest phases, because that's when you can have the largest cuts and not get into problems later on in terms of how I have to change systems, etc. How can be done? In theory, by combining all the aspects that you can see here, real-time information, the outcome of several actions, constantly updating the documentation, keep track of the assets, keep track of the maintenance schedules and the occupant feedback in order to improve the building operation, and also the financial management. And they have to be combined with environmental calculations of energy use, life cycle, and the targets to be met. However, it's not as simple as adding and just making, okay, let's make a big module or an API of everything together in order to have something. Some examples of tools that have been increasingly using the environmental planning include, for example, Autodesk Insight and Trimble Zephira, and they have a dynamic element that if you change the design, it makes the analysis. And this has been applied for the CAD programs and the BIM programs. They integrate energy calculation and daylight models, for example, for energy with Energy Plus. which is one of the interesting developments, and also daylight models in order to calculate by ray tracing how the influence of a certain change and if it meets a code, which is also important for practitioners because that's how they are developing their designs. They're not making much research, but just to meet the code. So it's better if they have some tool that helps them reach the targets. Some of these tools are plugged into commonly used software. So this means that an operator doesn't need to learn too much in terms of how to input the design, but they can extend their knowledge to what is being presented. Also, some of these tools offer the support from the conceptual stage with a diagnostic, as you can see in on the lower left corner. But even though it's still up to the user to apply the changes. So this means that the software is not making the change for you and not saying how much you have to change. They only tell you, okay, it meets it in a certain percentage, and if you start changing it, then it's up to the user to say, okay, yes, I will accept this change. So there is nothing like still like an output of several scenarios so that they can choose the element that is more suitable for the optimized design. In terms of building facility management, there have been also new developments. For example, IES Live, which combines the input from several operations and makes digital twin calculations of energy and emissions. Also, the demo consultants, this is a Dutch company. And what they offer is real-time monitoring from sensors, real-time optimization of the operations, also real-time tracking of energy use and calculation of emissions. They provide to the facility manager scheduling tools for the maintenance and inspection. So all this is being tied up together. For example, if you're using too much energy in a certain system, then it's might even put as a priority for the scheduling and to see what is going on. They connect with the BIM since they use the digital twin. They also have investment tracking, for example, how much money you have been putting on a certain element and if this needs to be replaced. And at the same time, they offer dashboards, as you can see in the upper left corner, that they show you how the building is performing in real time. So you can see, at least in a more advanced way, how if the actions that you are taking are having an effect. The software are offered as a whole or as a modular package. So you can either buy all the items that have been mentioned, or you can buy them separately, which is beneficial for different type of organizations. Also, I have to mention here, they do not have AI most of the time, but there is an opportunity to apply these novel techniques. The state-of-the-art tools have connectivity with different components within the system, and they are usually authored by the same company, unless it has been forced to use open standards. Also, there is real-time monitoring and insights provided, which is useful for the facility manager to see how the building is doing and take actions or propose scenarios. It analyzes several variables, which is also useful in terms that you can see certain aspects that maybe separately were hard to visualize. And also it helps to digitalize a very large number of processes, for example, the accounting, the emission calculation, etc., which makes the life of a facility manager easier. What they lack, and here are the opportunities that we can talk about later, is higher connectivity with the occupant. Let's say the occupants cannot really drive that they could change a certain temperature set point. This might or might not be convenient in certain organizations, but above all, it's a good way and an indicator to see if the building is meeting the expectations of the people that use it. Also, the tools are lacking a scenario assessment so that they can plan for the long term, for example, for 2, 3 years to 5 years, in order to have efficient carbon reductions. And this is translated to a suitable operation agreement that can be brought to the owner or the tenant. So this means that you can propose to the owner, okay, we are going to turn off the lights maybe half an hour earlier because we have detected that occupants leave at most at 5:30 and not 6 as it was scheduled. So this can be something that can be done, but you cannot really have this type of insight with the current tools. Also, it's still lacking in the current tools, the integration with the life cycle assessment, since the actual calculations can be time consuming and they use a lot of resources. So they are still under development, and maybe in the future they can be integrated. Some obstacles for the wider implementation, this is not what they're lacking, but why people are not really taking these tools so widely is because of the higher connectivity that is required. For example, you need a lot of IoT sensors, and then also a lot of tracking, for example, QR codes, and this can translate to an increased operation cost. For example, now you need to buy so many sensors. We have a certain electrical consumption. Also, there is a high requirement for computational power because it's not just one sensor, but multiple sensors. So then you need to use maybe a cloud solution. So now you're bringing new costs for subscription. And sometimes this is also part of what the strategy of the vendors, that they can sell their services, their subscription, but you have the risk of having a vendor locked in. This means that only the system of the vendor will work, and it's very difficult to change in case you find something that is different. Some organizations do not want to do this because it means that they are becoming dependent on a certain software company and not on a certain system to improve. At the same time, the companies that perform the energy management, they might find that this new approach requires changes in their policies. For example, now they have to tend to more people. They need to hire more people in order to handle all the user requests. And before, because they were just having one person controlling the HVAC system, now the cost also increases because they have to make a follow-up on this. So it also has to be taken into account in order to see that the needs of the companies, the occupants are met, but at the same time that we are reaching the climate targets and we have an efficient and real-time climate reporting. Some points on how to reduce emissions, I now throw my 2 cents on this, is to improve the visualizations in order to know how the building is doing. This will provide a better reporting, because at the moment you can only see what the software allows you to see. So this might not be always what the facility manager wants to see. So we need to have more customized views on how the building is doing, so that probably there could be also new type of insights that are not considered at the moment. Also, building monitoring has to be improved because it's better to have a more accurate picture on how the building is doing. I mentioned that it will increase the computational power, maybe the power consumption, the expenditure into the actual sensors, but this provides a better picture on how things are doing in reality, and we can reduce the number of assumptions. Also, it will be beneficial to increase the use of the digital twins and the artificial intelligence in order to plan the effect of the actions and enable self-corrections. Artificial intelligence can be good in order to know the patterns that the building is doing and then have predictions on what will happen next if the same behaviors are done. So this could be sort of an advice that could be given to the facility manager in order to have some new type of operation plan. At the same time, the documentation has to be improved in terms of the building assets, how they are being used, and to reduce their replacement. For example, in the University College Cork, as an anecdote, there is a system that via email, different departments are sharing if they are having a surplus in furniture, surplus in stationery, and then they offer it for the for the rest of the university to use. So this is an informal way to do it, but if it can be made in a more formal way, it can help to encourage a certain type of circularity by extending the lifetime of the assets and not having to buy every time a new one. So to finish this part, the smart facility management leads to smart building, and this reduces the emissions in practice. Now for the conclusions, and we didn't take so long. I will not take you so much time from you. The current tools are fragmented, and some of these are not fit for purpose of facility management because they were made for designing buildings. Also, the adoption of the advanced tools is depending on the organizational plans and the enforcement of the new regulations. Otherwise, we will just keep on the same situation, and this will be just a talk about future tools. Also, as we have seen, the new tools combine several aspects, but as you have seen through the interfaces, some of these might be too complex for follow-up. So that's why they need to rethink in terms of how the building is being used and how they are being maintained. There are opportunities available to interact more with the occupants as the drivers of the energy flows. As mentioned, they can indicate if they are feeling warm, cold, if there is too much light, etc. But it's not just to make them feel better by changing it, but by taking into account what is going on, maybe making an analysis how often this is happening, and then trying to take a corrective action. But of course, this involves more analysis, and probably there is a combination between designers, engineers, and facility managers that can be exploited here. Also, as mentioned, because of the large amounts of data that are generated, there are opportunities for new technologies such as artificial intelligence, so that new modes of operation can be suggested, and also how to reuse the assets. As I said, the pattern identification can be very useful, and also when you have a long-term operation, this can help you automate even more the facility management and get a more accurate ways of reporting the climate targets. Also, dynamic life cycle assessment needs to be integrated for true environmental reporting. There is work being done, and we will see about it later. So this is on the way, so it's something that is quite positive. And as I mentioned before, smart facility management leads to smart building management. And with that, I conclude my talk. And if you have any questions, I'm happy to answer them.
Yes, Carlos, many thanks for your talk. And I think we have prepared 2 responses. And the first response will be Steffen Robbi. Steffen, is your presentation also ready?
Yes, quite ready.
Michael has his hand raised. Maybe we can, or do you want to say congratulations? Okay, yeah.
Yes,
Thank you.
Okay, because I think first we would maybe give the response from the 2 other speakers. If there's a question, then we will be happy to have it on the panel, and then I also will give the floor to the auditorium. Steffen.
Okay.
Normally in the middle, you have a button on share your screen.
Yes. Hopefully, no, that was the wrong one. Not this one. I'm not used to.
Yes. Looks very great.
Can you see the screen? Great.
Yes, Steffen. So the floor is yours, the screen. Yeah.
Okay, thanks a lot for the invitation. I will try to take up some notes of Carlos. I will concentrate my talk on the example of circular economy, circular construction, and explain you why I've chosen that topic. I'm planning to give you some insight. Carlos has already addressed regulatory environment, and I think Michael in the beginning as well. There is a lot of changes, and I give a brief introduction on that. Stressing just for the example, some technical criteria of the EU taxonomy, and highlight the principles of circular economy on the process of refurbishment of a building, and how to address that, or to come to a conclusion why we need new digital solutions to address these challenges. So we already heard that, or we already know that the construction industry plays a major role in energy demand, but also resource demand. Globally, we take up about 38% of global CO2. We are responsible for about 38% of global CO2 emissions. That's basically the energy demand of buildings. But what is also very important, the construction industry is not just a topic about energy demand, it's a topic about resource demand as well. And just the amount of waste here in Austria sums up to 76% of total waste by the construction industry. So that's a huge share, and that's why I have chosen circular economy to discuss with you how advanced tools can help to address that problem. Before we go into tools, we need to understand the principles of circular construction, and without going into detail of all of that, there is a lot of theory behind it. It comes all down to 7 principles. Our aim is to change our economy. Basically, it's an economic process from linear economy to circular economy, and that includes 9 steps. The first and highest principle is to not use resources. So in that case, the best building, the most climate neutral building, as you called it, is a building that is not being built. That means refurbishment, refuse to build new, rethink your process, rethink your design, and reduce the amount of resources that go into that. That's the highest principles, and only then apply the principles of expanding lifespan of products and its parts in terms of reuse, repair, and refurbish building products and materials. And only then at the end we come to what we all know from private circular economy, things like recycling or recovery of products and materials. And this is not just something we know as experts in the building industry. Also politicians are very much aware of the resource efficiency. The demand is driving demand for resource efficiency, and within the European Green Deal, resource efficiency is playing a major role. So the European government doesn't only try to decouple energy demand from economic growth, but also resource demand from energy, from economic growth. And as we have already heard, the taxonomy regulations play a major role in achieving these goals with standardized classifications on what is sustainable. Before that, we had a lot of ideas and a lot of goals, but nothing happened. Then they have set up expert groups, big expert groups that all came to the conclusion: our goals, our measure. We don't have measures in place that help us track and monitor development. So, taxonomy regulations provides a clear set of technical criteria. And it's not only criteria, but also the way we have to report. There's a lot of obligations now for big companies and also SMUs now for reporting. There's CSRD standard, there's CSRS standards. There's a long list of regulations. I didn't want to include, bore you with regulations, but it's a very clear set of regulations and criteria on what and how to report that is just now falling into place. And in Europe, we'll see a big change, and we already see the big aim of that is to change the flow of investment. So it's actually the idea, I didn't say that, the idea on the taxonomy regulations to change how investors invest, and they try to change the flow of money into green economic investments. And there are 6 goals: climate protection and climate adaptation are already published, and the latest publication is the aim of transition to circular economy. And within all of these aims, as I said, certain sets of criteria are published, and all of our, and not all, but a lot of our latest regulatory framework refers to these criteria. See, EU action plan for circular economy, in the development of digital law, the digital product passports, or the eco-design framework, just recently published now. Also, national regulations, we have a circular economy strategy, we have an action plan for public procurement, we have now, or we will have now, in 3 years, we just have seen a draft last week ago, National Buildings Directive, and also local levels, and they all refer to these set of criteria that have been the EU taxonomy. And just to give you an example, what I'm talking about, what's in there, the things like that we have to report primary energy demand by energy certificates. We have to report or show the results of air tightness testing. And very important thing, as I said, it's not only about energy. There is a strong shift towards resource efficiency. We will have to, and already, but will strongly have to report the global warming potential. That means from all the material products we have, the CO2 footprint, how much the CO2 is bind onto our material. That's pretty new. And also, not only that, I don't want to go into too much detail, just to highlight one other criteria that's directly addressing circular economy is that we have to show and report how much reused or recycled material we apply in our new or refurbished buildings. So a lot of new data about materials, not only energy, but about materials and products. And I think that's quite a new thing for us. And and that also requires new planning methodologies. If we want to address that on the example of refurbishment of a building, we have to change the way we address refurbishments. And that's basically the first two the big changes we have to when we after we have taken up an inventory of all building stock. So if I want to refurbish, I'm here at the point in a very beautiful old building in Vienna. If I want to refurbish that, normally I would just try to get some plans, and then I would just take down everything old I want to change, deposit it, and start with the new planning. Now, after I have really taken a lot of effort into the inventory, I have to create detailed plans or detailed geometric models. I have to evaluate and I have to consider what material is in there. I have to evaluate that in terms of a potential analysis for reuse and recycling. So I have to the doors, the windows, walls, floors, everything. Is there something I can reuse? What's the potential about recycle? Or only in the last step is it necessary to deposit? And that's not, and that becomes more an obligation for all of us. Then we don't deposit, we do a recycling-oriented dismantling. Very important. And the last, that's why I say it all comes from the need of sustainability reporting and certification of our buildings. So digital models of our building will become a major, let's say, a data hub, because we need here to report how much, what kind of material and products is in my building, and what is its CO2 footprint. In terms of refurbishment, we need a detailed analysis, inventory stock, point cloud systems, material qualities, quantities. A digital model will play a central part, and based on that, we do create a digital material passport and other analysis, which I will show you. I will just lead you through the steps. 3D capture, data capture, is always done in 3 steps, basically, no matter what technology you use. We start with, I'm here in my old building that needs to be refurbished. I start with creating plans or digital models. I have to do data collection, then data analysis, the change from a point towards a model, and then, of course, the reporting. Technology-wise, we have a whole different, depending on the application, the building, and so on. We have laser scanners, LiDAR scanners, camera systems, and they are plugged onto drones, robots, and what is widely used, mobile portable devices. They are very fast now. They become cheaper and cheaper. This is a backpack that is very often used here in Austria, at least. You just put it on your back and walk through the building, and it just takes minutes to create or to get a digital model, point cloud systems, 3D model of your rooms and of your buildings. A development that's still the big effort is here from a point cloud towards a digital model that I can use for further on planning. That's how AI, artificial intelligence, comes into place and will play a major role in future. I'm very happy that we find, I could show you a big list, just grab one example here. There are more and more startups that try to apply AI to this process and try to automatically create digital models. Either camera, pictures, point clouds from laser scanners, and so on. Or what I think, I hope, it's all very new, but I hope it will become very common, is to use LiDAR scanners of your latest smartphones. Every one of us has a LiDAR scanner in our pockets, and there are some pretty good tools now. I've tried it out, and we have tried it in our office. It just takes minutes to get a really nice digital model of rooms or buildings. And it's very easy then to put point of interest formulas, and it's automatically classifying, is that a wall, is that even my chairs, my tables, doors, windows. These systems are getting much better, and I hope they will play a bigger role in the future, or I'm sure they will. At the moment, as I said, the biggest effort is the change from, if you have a point cloud like here, a laser scan, to get it to the model, digital model. That's taking the biggest effort, but this will change in the future. If you don't know what BIM is, basically a very simple explanation. BIM is basically 3D plus information. Actually, it's not so, the 3D elements, the 3 dimensions, actually not so important. The important thing is that to every building element, we can add different informations. And in our case, it's informations about material, informations about deconstructibility, about what we need. So we have 2D, we have 3D, and we have BIM. BIM gives us the example to classify our elements and then do automated calculations. That's the big aim, because we don't want to do this reporting and calculating and optimization manually as it's done now. And just a few examples on how that works. We have our building elements. They are linked to property databases, material databases. So we get structured material and quantity information. So we have our models, we have our elements. Here a wall, and it's linked. The thing is to use a database. This is just, I don't want to do advertising. Skyco is a young company here in Austria. It's linked to Bauburg and Ökobau. These are two, in the German context, two big building product databases. So they link it together, and then we can do a lot of calculations as, for example, the global potential, and of course, after that, reporting and evaluation. So that happens automatically, and it's very nice within the design process, because you can then change materials, you can change wall elements, and it's interlinked with each other. So automatically you see what the impact is on your CO2 footprint. There are more, the amount of companies who offer products is more and more increasing. One of the first ones was EPEA. They offer a circularity passport, but the system Madasta is very popular in Austria at the moment. But the process, the methodology is always the same. I have my digital model, I have a BIM model with all the elements, and I connect it, I interlink it with a product database to do calculations for the material footprint of my building. And this is, I would say, well, state of the art would be, this is advanced, you call it advanced tools. Future tools, what is missing, I would say, is what we have seen from Carlos, what's already coming in terms of energy performance. Autodesk, Revit, and others, they offer plugins and tools within the authoring tools for energy performance evaluation. So that's existing. In terms of CO2 footprint material analysis, that's not available as far as I know. But there are first companies offering solutions like, what's the company's name here, the Werkbank. I think Dresden Sommer just bought it recently. They offer, it's called BIM and more. So within your design process, Autodesk Revit or Archicad, you have the link to material databases, and do your global warming potential or life cycle analysis and so on. And that, I think, will be the future. There are just first applications now, but that will be, as I assume, that's my prediction, a very standard process in 5 years. So that you get your footprints and your analysis and your performance certificates, like you have your energy performance certificate. So you will get the global, called building resource passport automatically as part of your design process. So that was it. I hope I wanted to address your very specific topic that wasn't very broad, specifically on the circularity, advanced tools for circularity. I hope that was still interesting. We are an innovation platform doing a lot of research and also knowledge transfer. So I hope there was something interesting for you. Thank you very much.
Yes, Steffen, many thanks for your deep dive into digitalization. I would then like to pass the screen to our next speaker, who is Salvatore Carlucci. I can already see you. Hello, very warm welcome.
Hello, everybody. Thank you very much. Just share my screen.
Yes, please. Okay. Yes, it's working. Perfect. So the screen is yours.
Thank you very much. Thank you very much, Alexander, for the invite and for mentioning something extremely important, that is the challenge that you and opportunity that you is offering to all of us with the new revision of the APBD expected to be approved early this year, 2024, that is expanding the calculation border for the assessment of the performance of buildings. And in these regards, speaking with Brigitte some months ago, came up the idea to develop some kind of discussion, this response basically on how we can support advanced design capable of tackling this new challenge that we are facing. And here I'm summarizing some concept of mathematical optimization that we have been using for some years now, mostly in research, also because currently is a tool that is start getting used into the practice, into the design practice of buildings. Sometimes simplifying some steps, in other times not really exploiting all the potentialities that these techniques can offer to the user. So I would like to start trying to answer a question. Why do we need to speak about or introduce building performance optimization as advanced tool to support design of building? Simply because basically a building is something that needs and must accommodate different needs. And often these needs are not similar. So while some stakeholders in the process might be interested in maximizing some performances, others stakeholders might be interested in reducing that specific performance. So the issue is, what is the best solution according to all the degree of freedom that we have during the design of a new building or the design of a refurbishment intervention? It is exactly here that building performance optimization can help us in supporting the design process in a very efficient and effective manner. So basically, there is this bar here that I cannot avoid this. Okay. So basically the building performance optimization is a quite versatile tool that can help us in taking into account the different aspects related with the building design and try to combine different solutions and helping the designer team to converge towards what we will see are the most suitable building variants. Here we can take into account geometry of buildings, and most recently we are introducing concepts like parametric design. Envelope performance, we can consider different building components and different performances for each of these components. We can take into account active systems. We can introduce renewable energy systems, also including solutions for energy storage. And we can assess different performances, comfort base, energy base, daylight, embodied energy, whatever you want, whatever can be calculated, life cycle costs, life cycle emissions. So it's a very versatile tool, but needs to be controlled. So we have many tools that can help us, in particular in estimating the performance of buildings. Up to some decades ago, we made this study where we identifying something by about 400 tools for simulating the performance of buildings, but only 18 tools at that time were dealing with the issue of guiding the designers towards an optimal solution. So it was still a branch of the computational design, building design, that was not fully deployed. And basically what happens is that these optimization tools, most of the time, could be coupled or combined with building performance simulation tools. So this is something that we have to keep in mind, because there is not just one standardized manner of running these techniques, but we can have different options based on specificities of the problems that we are addressing. But what is optimization? So basically, we have to introduce just a concept. I will not present any equation, nothing like that, just to understand what is it. So mathematical optimization is a family of methods that aim to select the best element with respect to some given criteria from some set of available alternatives. This set of available alternatives is called the problem space. It's basically what is in the mind of the designer as all the possible opportunities that basically can be combined in order to identify the building design. In the way in which we consider optimization of a specific problem is basically identifying the minimization of an objective function by choosing input variable or design variable, which constitutes together configurations, building configurations. And these configurations are taken from the larger problem space. So basically, we could say that optimization means to find the minimum value of some kind of function that is computed in building performance simulation tools like Energy Plus, IDICE, ISV, and so on. Most of the time, this optimization project is subject to some constraints. We could have equality constraints or inequality constraints. So these are aspects that can give a shape to the process of identifying the best solution. Given this, basically, what is the objective function? Objective function is what the benchmark, the performance that we want to optimize, that we want typically to minimize. If we want to maximize an objective function, it's not a problem. We just typically what we do is we just write the inverse, so minus the objective function, and then we minimize. Typically, what we have found in the literature some years ago after systematic literature review, most of the studies up to 2015 were using as objective function sort of energy-related matrices: energy use, delivered energy, primary energy. Economic. The second category was economic, so some kind of cost could have been payback time, capital cost, whatever. Matrices built for representing thermal comfort, then for visual comfort, environmental impact, and then indoor environmental quality. Finally, there were a few 7-8 studies with other objective function belonging to different categories. But how many ways we can combine this objective function? What we have is that basically we can set an optimization problem choosing only one objective function. In that case, we call it a single objective optimization. And in this case, we can look for the best solution. So the best solution that basically is the global minimum of this equivalent function that we want to minimize. If we try to optimize a building performance with respect of two or more objective functions, then we speak of multi-objective optimization. And this is a little bit more complicated. And basically what we look for is the non-dominated or Pareto optimal solutions. We will discuss just in a while about what are they. There is also a third approach that is basically a sort of in-between, or actually is a way to transform a multi-objective optimization into a single objective optimization. So basically what we do is we take the two or more objective function, we combine them using a sort of a priori formulation, equation, and so we transform the set of objective function into one utility function that then is minimized like we used to do with the single objective optimization. We will show a couple of examples at the end using the scalarized optimization and the full multi-objective optimization. So when we speak about single objective optimization, the result is this. So we have the objective function on the y-axis. On the x-axis, we have the number of simulations that we need to run. And of course, this depends on the complexity of the problem that we are facing. Here, for example, we have something about 1,000 simulations, and this is the value of the objective function. You see, so we basically change the values of the design variables, we compute the performance, and then we see that our tool helps us in reaching the minimum values. When we achieve some stopping criteria or we reach a minimum, then so the simulations, the optimization run stops, and we can get the best value. For multi-objective optimization, the situation is a little bit more complicated. Assuming that we have just two objective functions, function 1 and function 2, basically what we have is that solution belongs to the larger problem space, and if the objective is to minimize both F1 and F2, then it's very likely that we end up having a sort of this kind of I hope that you can see my pointer, this kind of line with some kind of distribution of building configuration here, 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 and other here. Basically, the non-dominated or Pareto optimal solution are the set of those solutions that cannot be optimized with respect to both objective function, but both objective functions. So for example, if we take into account the E solution here represented, this E solution is in value for F1 less than C and also equal to B. So basically the value E is dominating the C. If we consider also F2, then the configuration E has a value that is lower than C, lower than B. So basically the value E, the configuration E is better than B and C. While we cannot say whether D or E is better because both of them are reciprocally better with respect to one of the objective functions and not the other. So for example, with respect to objective function 1, D is characterized by lower value than E, so it's better. But if we look at the function 2, then the solution D is characterized by higher value than E. This is the set of solutions that we look for, and from which we have to extract some kind of decision support mechanism. The scalarization optimization, what is, as I told, a way to combine two or more objective functions into a mathematical expression. This mathematical expression is set a priori before running the simulation, and so we translate a number of function f, 1, 2, 3, 4, into just one utility function u. We have different ways. These are just three, the most common. This one is basically to sum the value of the different objective function weighted for a coefficient. Basically, the ratio between these two coefficients indicates the slope that we use to analyze the problem space. The weighted exponential sum, basically we multiply our objective function for a power, p. We can also add some weighting factors, and then we can try to investigate the problem space using these family of locus that have different shape. The last one is quite interesting because basically it multiplies the two values of the objective function. Why? In particular, when we have objective functions that could be characterized by values expressed in different order of magnitude, of course, if we sum them is a problem, but multiplying them, we can keep, we can consider the variation of the values of the two or more objective functions. The issue is that we can, at the same time, consider a solution to be optimal or not based on the scalarization function that we used to generate our utility function. So this means that we have to be extremely careful to understand how to set this, make some check in order to understand also what is the shape of the problem space, whether it is convex or according to the shape that the problem space has. In practical terms, how many tools we have in order to run a simulation? Several, and for the specific case of building performance optimization, we see that most of the studies at 2015 used Energy Plus, The second tool was Transys, then IDIs, Radiance for daylight simulation, ESPR, and then MATLAB and other tools. We see here also some tools integrated like BOPT and Opti+. Athena was one tool used for life cycle emissions. On the other side, among these 18 tools that we mentioned, which was the most used tool in 2015, up to 2015, it was GenOpt, developed by LBNL in Berkeley. Then we had MATLAB and other programming codes. Then we saw at that time also process automation tools like Mode Frontier being used also for application in the building sector. These are tools that are mostly used in other sectors like naval or aerospace industry. So that was quite interesting to see this shift of competencies and skills. Let's sum up what we've told with an example. So what we tried to do was basically to try to implement the previous version of the EPBD that introduced the nearly zero energy buildings, and to combine it with the European standard EN 15251 on basically environmental quality in buildings, where stated this standard that any energy declaration without a declaration related to the indoor environment makes no sense. So what we wanted to do was to design an automated process that could help us in achieving a comfortable net zero energy building, considering all the energy uses. So what we did was try to develop matrices that could explicitly take into account thermal comfort, and we did in these papers that you can find here. And basically, we implemented a two-step optimization procedure according to what the standard suggested. So first, we start dimensioning the passive means to prevent overheating in summer, and we extended also to winter, referring to the adaptive temperature limits showed by the standard itself. But if those conditions cannot be guaranteed only by passive means, then there is a second step where we introduce mechanical cooling and heating systems that at that point can help us in getting comfort condition expressed according to the Fanger comfort model. So first step, optimization of passive means using long-term thermal discomfort indexes with respect to the adaptive comfort model, and the model was run in free floating. The second step was to introduce active systems, optimizing with respect to primary energy, and this was called condition scenario. What was the specification of the project? So to identifying the optimal design choices, design variables, to minimize summer and winter thermal discomfort in order to have a comfortable net zero energy buildings. We introduce a number of design variables, in particular 9 different conditions for external walls. Basically, we express on 3 levels the transmittance, thermal transmittance in steady state conditions, and the 3 levels for the inertia, so the time shift. The same thing happened for the roofs, where we had 9 solutions, and for the floor, again, 9 solutions. Then we had 6 different glazing units. In this case, we could identify these 6 solutions on 3 levels of thermal transmittance and a solar heat gain coefficient, differentiated by each of the 4 expositions. 3 strategies for shading control, 2 strategies for night opening of pivoted windows, and 3 strategies for night opening of double leaf windows. You know, many building configuration could we have, or we combine permutating all of these, something that is more than 17 million of building configuration. Of course, it's something that cannot be simulated. So optimization algorithm helped us to solve this problem. We used, in this case, a scalarized approach with a weighted sum approach. And we use a particle swarm algorithm with 20 particles and 30 generations. This was applied to a building that was located in a real project. It was located in Sicily, in particular in Mascalucia, close to Catania. And the architectural inspiration was old Sicilian houses like that, and this was the sketch from which we started. You see here the thermal zoning that was chosen to represent this building, and this is the results of the first simulation. So basically we have the utility function, the sum of the squared values of the long-term discomfort index for summer and winter. This is the number of simulations that we set, 600, and this is the value. If we graph all these results on a bidimensional graph, then we see what is the outcome. So here we have sort of Pareto frontier, but in any case, we have one value that minimizes the sum of the two power values here. What was the impact of this best solution? Well, this building is according to the free running mode that I mentioned at the beginning, the free floating scenario. And so we have no heating, no cooling. This is in dark, in black, the temperature inside the dining room. And what we see is throughout the year, basically the temperature in free running is almost completely within the 80% acceptability according to the ASHRAE 55 boundary. So this is quite an interesting result. And of course, while the climate in Catania is quite mild, we have in any case some higher temperature that spike up to 35 degrees and lower temperature around 0 degrees. To achieve net zero balance, what we did, so basically we estimated the energy needed for domestic hot water, ventilation, lighting, and electric equipment, and we introduced some PV panels and PV panels that you can see here, 13 panels, that basically enable us to completely cover the demand of the building, actually generating much more. And we had to purchase energy on a monthly scale only during winter months, from basically November to February. But we have a quite large excess from March to September. Let's assume that we want to introduce an air conditioning system. So the set point is switched from the adaptive comfort to the Fanger comfort, with set point around 21 degrees and 26 degrees with category 2 boundaries. Then again, we see that we are very much into the boundary of the model, but in terms of energy, what that means. Now we need, of course, some energy used for space heating and cooling beyond ventilation, energy for ventilation, domestic hot water production, lighting, and electric equipment. To cover the yearly energy, we need to increase the number of PV panels to 20, but in this case, we are almost again capable of covering the monthly balance. We need again to purchase energy from the grid in November, December, January, and February, and unfortunately also in August. So basically, it's definitely possible to design net zero energy buildings. I want to show you last two slides about the same building, but in this case, modeled using not a scalarized approach, but a fully multi-objective approach. In this case, we wanted to optimize 4 different objective functions. The first objective function was thermal discomfort in summer, thermal discomfort in winter, amount of light, and then glare risk. And we had to fix the air change rate for some reasons. So the outcome in this case is quite complex because it is expressed on a 4-dimensional space, so it's an hyperspace. Therefore, we cannot represent in 3D. So what you see here is the 2D projections of this 4D solution space. The dark points here are the Pareto optimal solution. As you see, it's not very clear one tendency. There is just one graph that is very similar to the one that we saw in the previous optimization, this one. The other are very complex. What this means? Basically, this means that if we look at the 25 most best solution belonging to the Pareto frontier, actually we cannot see a clear trend here. So all of these solutions are good. But what we see basically is that the two objective functions related with the thermal performance of buildings do not vary a lot between those 24, but the performance with respect to the amount of light and with respect to the glare risk vary quite a lot. So small variation in windows and strategy for controlling solar shading could have a strong impact on the visual comfort perceived inside the building, while this impact is not as greater in terms of thermal behavior of the building. This is something that we have to keep in mind. What that means? It means that basically multi-objective optimization is a very powerful tool, but we need to be extremely careful in understanding what to take and why. So to sum up, what we can say, optimization is a very powerful and versatile technique. If we can calculate something, we can use it into an optimization problem. It can effectively support informed decision-making. We do not just choose one best solution, but we can understand why that solution is good. It's a valuable tool to support design of net zero energy or emission buildings, because setting a target, then we can identify how to reach that target. But at the same time, we have to keep in mind that we need to have some computational competences. We need to have a control protocol to properly get the results and understanding those results. We have to keep in mind that scalarization, a priori scalarization, is a simplification tool, but it forces the results. And multi-objective optimization requires some kind of a posteriori decision-making selection process. There are some techniques, but this becomes a little bit more complicated for adoption in practice. The final comment is regarding the objective function. While in theory, there is not a limit in the number of objective functions that we can set, the issue is that if we have many objective functions, it's very complicated to understand what the best solution mean, because it's not simple to understand how variation in the design variables will affect the final results. And with this, I would like to thank you all, and to thank Carmelo Sapienza, the owner of this building, and Lorenzo Pagliano, that was developing this study together with me some years ago. Thank you.
Many thanks, Salvatore, for your nice talk on building optimization. So there's a stop sharing button if you would like to.
Yep, I'm looking for it. Here.
Yes. Thanks, Hannah, for sharing the speakers list again. So first, we would like to ask some questions to you, all the speakers as a panel. And I think we learned that there's quite a high challenge we need to address. And my first question to all of you would be, if we learned about the Green Deal and the targets that we need to meet until 2050, also building refurbishment plays a crucial role. And so I would like to learn from the three of you how you would position building refurbishment to cope with the climate targets. Maybe I can start with Carlos first, and then we go to Steffen, and then to Salvatore. And in the next round, we try to have a different order. Carlos, how do you think about refurbishment?
Thank you, Alexander, for the question. Yeah, building refurbishment, it's, I would put it as a high priority activity, since it's the element that will allow the buildings to change their behavior from what we have now to the desired behavior in terms of energy, emissions, comfort. However, it's not that easy to say, okay, let's do building refurbishment of all European buildings. There are different factors, both technical, human, economic, that don't make it an activity that can be undertaken so easily. So yeah, from the theoretical point of view, yes, it should be a priority. But this is affected by all these other factors and must be considered as well.
Okay, many thanks. Can I pass the question to Steffen from digitalization approach? Steffen, how would you position the topic of refurbishment?
Much more complicated than new buildings, planning and construction of new buildings. We see that the stagnant refurbishment rates in Europe. It has a lot of, I think the least complicated part is the digital part, the technical aspects. It's more about, it's a lot about regulations. It's a lot about financial aspects. We really need to change because often what I see, especially in particular in Austria here, a lot of projects are hindered by, or let's say like this. Very often it's much cheaper to just demolish an old building and erect it from the scratch than just than refurbishing it. It sounds strange, but that's what we see a lot. A lot of regulatory aspects, and but it's key. It's one of the major tasks if we want to address climate change. So it's very crucial that we make the shift. And I think the European Union has just, I don't know the figures, has just published a new budget for refurbishment projects. Not sure if you know it. Very big figures on investment support.
Yes, many thanks, Steffen. Salvatore, in terms of optimization, what do you think? How could that contribute to our refurbishment task?
Yeah, definitely I agree with all of you. The real challenge and the real opportunity is the deep renovation of the existing building stock. The challenge because we have to consider it not only as a technical problem, as Peter was mentioning, in terms of what performance the new components must have, but in a sort of integrated manner. Of course, we cannot bring to zero the emission of all the existing building stock. This has to be accompanied with other measures, like, for example, greenification of the energy mix of the countries and measures like that. These impacts also in the terms of finding the right balance between investments, cost, and also opportunities, because the large-scale renovation projects are also an opportunity for generating new green jobs. But of course, they cost. Who is going to pay for this? In which manner? In which kind of strategies? Optimization could be a way, if we have a model that can put into account different dimensions, different objective function, to test strategies, to understand what is the implication of adopting some strategies instead of other, identifying some target values that, for example, the new version of a PBT4 is setting new ambitions. So we have to upgrade a given percent. Then member state, we will maybe adjust this percentage, but basically this is an outcome of an optimization task. Specifically speaking about individual buildings, optimization and building performance simulation are absolutely important in order to take the right decision, not wasting money. We have no time, no resources to waste. Once that we touch new material, new buildings, existing building or new intervention, let's say, we must really do the right thing, and this advanced tool can help us in achieving this.
May I add to I think optimization, in particular in refurbishment, really plays a major role. We see in many projects that just the building performance can be increased by 30 to 40%. just by applying optimization algorithms, by applying sensor data, by and monitoring data, monitoring systems, sensors monitoring systems, and smart evaluation algorithms. And it's not even, very often it's not even necessary to do big investments, but just a matter of better operation of existing technical systems. Switching, as we have heard the example, switching off the lights at the right time, not overheating, not using rooms that are not that are not occupied, and so on. There are hundreds of examples where with just easy and simple measures we can save up to 40% of the energy demand. And optimization. Yeah, sorry.
Yes. Yeah. Many thanks, Steffen, for your quick reply. It should also be a fruitful discussion. So please always feel free to raise your hand or comment if you think it's you want just to build upon another question. One of the big challenges I would also like to ask all the three of you is we learned that the EPBD calls for zero emission buildings, but it's not only the energy which counts, but also the materials. And with all the materials needed for new technologies, but also for building materials to be put on buildings for insulation, for example, there comes the trade-off with embodied energy or embodied greenhouse gas emissions. So I would like maybe now to ask Salvatore first, how would you position the discussion on embodied versus operational emissions from your perspective?
Yeah, very interesting question. I'll answer recovering my previous experience in Norway at NTNU, where we start designing. Norway was quite one of the beacon in expanding the life cycle to include also emissions of operations, materials, construction phases, introducing one of the first certification approaches. And of course, a lot depends on the availability of materials, techniques that are typical. And this poses a big challenge in different systems. So what was possible to use a structural framing in timber, for example, in Norway, is not possible here in Cyprus, because basically that solution is not available. So what is the challenge here? Of course, identifying material, high performance material that really have a lower impact on the earth. On the other side, generalizing a statement that we used to say 20 years ago, the best emission is the emission that is not needed. So this calls for real rethinking the design construction process of building so that the concept of circularity is fully embedded. The concept of modularity, dismounting is really embedded. So because buildings tends to increase or change their performance, or people in the way in which buildings are used, we should think building as not a steady state elements that we build once and then they will stay there for 50 years, 100 years, 200 years, and what happens, but something like our cars that has to go into periodic maintenance processes and actually be capable of dismounting, upgrading, remounting components. And this has to be done learning from other sectors, automotive, aerospace industry. We have to, I think, to get out of the prototype approach that we typically use in the building sector. Each building is a unique story. Where we take just some examples. We should rethink the way in which we design, construct, manage, and maintain our buildings.
Many thanks. I think now that paves already the floor to Steffen. If Salvatore was saying every building is unique, how can digital tools help there in the process of the building design and coping with the challenge of embodied emissions?
Well, I would just like to comment on Salvatore. He said that we could take a look on industrialized processes like car manufacturing. I think just like to add, even in car industry, we have, I don't know the English word for Losgröße. What is that? Like the amount of how many cars of one type we manufacture. It's less than 10. We are getting close to one. It's something very low. It means that we have a lot of standardized sub-products and elements, but there is a huge amount and capability of customized customization is playing a major role. So every car has the same elements, but a very unique total design. And I think that can also refer to the building industry. I don't want standardized. I mean, I grew up in East Germany. We had this huge areas of modular buildings, and every architect now is afraid of when we say the word modular design and manufacturing. I think having that pictures, that old Eastern pictures in mind. That doesn't need to be. It doesn't need to be that way. We have to distinguish between industrialized production with a high amount of highly standardized elements, like in the car industry. That will give us a lot of. That will increase the productivity, the energy efficiency, and so forth. But still having very individual building surfaces, building designs, and in order to do that, we need digital models. We need digital design. It doesn't work. I mean, we need highly standardized, highly industrialized manufacturing. Needs digital tools, digital design tools, and we're working strongly on the interlink between digital design models, generative design. You probably heard of these terms, BIM-based generative design processes that is possible to directly interlink with manufacturing. That works very well, and I think that will be a big part of the future. In particular, also for refurbishment. Serial refurbishment with pre-manufacturing will become very important.
Many thanks, Steffen, for that. So maybe last but not least, Carlos, also a lot of already mentioned. Would you like to add something from your personal point of view to the discussion?
Yeah, thanks, Alexander. I think it's not only the optimization, but also the source of the materials that it's the new EPBD is forcing more recycling, also new solutions, for example, nature-based solutions. And this also poses a challenge because materials have a certain limit. So again, it's optimization problem in a way to say how to have the best insulation and performance with the least emissions from an embodied point of view. So obviously you can reach the mathematical solution, but then bringing it to practice will be the interesting part, since it will make to see if this is practical, if this is economical, and if it's even buildable, because we could end up with a lot of cellulose insulation that it's too thick and then becomes impractical. But I think it's the challenge. So if we are not faced with the challenge, we'll never pass from the existing situation.
May I add to that? I had a very interesting discussion with an Austrian company who's really big in prefabrication, really innovative, called Monsberger, and they set up a company for modular prefabrication called CRE. And I talked to the CEO, and he said, you know, Dr. Robbi, you know, all this mathematical optimization, and we can do really optimized piping and insulation. But, you know, at the end of the day, I really need something that I can manufacture very smooth, that I can assemble on site extremely fast, and that fits in my logistic lines. So just adding to Carlos' statement, the perfect, the whole environment of logistics, production, and so on, it's a very important other subject, and it's sometimes, yeah, we have to find the optimal between the two.
Many thanks, Steffen, for that. I would like also again to use the opportunity to ask for more questions from the audience, maybe. So if there's some questions, please also feel free to write them in the chat or raise your hands. If you raise your hands, then we see if there's a question from the people. If you would like to speak up, unmute yourself, and also please turn on your video camera so that we can see who is asking for a question. And please state your name and affiliation, if so. So is there some questions from the audience? If not, maybe then I can ask one more question between, but everyone is free to ask questions also in the meanwhile. So we also learned that we need the people to support our transition, I would like to say. So it's stakeholders, but like cities, so different actors. From your personal perspective, who would you like to address, to call for actions first as stakeholders? Maybe Steffen, I could start with you now.
This is a really good question. Difficult one for the finish. I don't know. I think
you have the tools, but you know, whom are you giving the tools to, and who will make the decision at the end?
Yeah, I think you know, I'm a big fan of small steps, and I think everyone has to do small steps, and it's all, we are like an interlinked. How do you say? Monsberger, an interlinked. So everyone plays a big role, and even though we do small steps, I have noted in the energy transition, like there's some political activism. You know, we prohibit straws and plastic bags, and you know, I'm wondering about the impact. So, but I think everyone can really have an impact as a private person in his choosing choosing the products we buy, choosing like if the kind of car I drive, where I live, how I create my life has a big impact on our resource, on our consumption. I mean, I have a, you know, in Austria we have one of the highest highest consumptions, resource consumptions worldwide. So if we ask someone to change, I think we have to start with the change. We cannot put the fingers on anyone else. We have to charge in our energy consumption, and we have to start with reducing our resource consumption. So, and that's basically the way we live. We have to change. But then, of course, politics, and that's what we see actually. I'm in the business for, I don't know, 20 years about, probably, after PhD. And I've never seen such a quick and big wave in the building industry as I see now after the publication of the EU taxonomy. Because with that we have a strong political commitment and regulations really addressing the financing sector, and everyone is getting nervous, and everyone suddenly starts to use building certificates, and the whole thing is getting real. So political will has a big impact, of course. Yeah.
Then I can ask Fabio, Montignano to speak up. Maybe he has some questions, some comments in the chat. Fabio, would you like to let us know your thoughts?
Well, I can say a few words because it's
Yes,
I see that it's late, so and the question was already touched. But you know, the issue is that it's not also about people, it's essentially about people. I mean, it's like an iceberg. We see the top, that is technological developments, but you know, everything is related to what people will decide to do. And that means that, okay, it's a matter of knowledge and access to solutions. It's a matter of making the right calculations and understand what is more suitable or not. But whenever you decide to invest your money from your pocket, or you get access to incentives, or you are going to ask for a loan, it's a dynamic that's among people. And I must say that, you know, what happened in Italy, I was mentioning in the chat, it's the roasting that may happen because we had a boost and everybody was going there and refurbishing. And at the end, we had something like 4% or 5% of the buildings, which is a good, I mean, it's a good progress if it would have been steady. But change of government, mindset, change of policies, everything is back to zero because there is nothing now except the ordinary incentive, which was quite a long time before any taxonomy and any commitment from the EU. And now people are scared because they say, okay, if I start, then I will be locked in and with my money, and I will know what I'm getting from the investment I'm doing as some tax relief. So my always concern is that in technological discussions, we need to bring the system around. And that means that we need more and more to put people with different backgrounds and power in the discussion in order to try to make the system work, not just the technology. Yeah. Point, but I think that it was appropriate in this discussion.
Yeah, many thanks, Fabio. I think you're fully right. It's also about acceptance at the end. You know, we need to have the people behind us, and the people also need to do it, and people need to ask for it. So you're fully right. Carlos, would you like to share some more comments? Whom you would like to give the power for the change? Which
well, I think as Fabio was mentioning, that has to be a bottom-up approach, because so this means that we have to reach first to the people, which is practically us using the buildings and the built environment, because otherwise there are misconceptions and people feel threatened. For example, what happened with the farmers protesting because they were thinking, oh, we're going to lose our livelihood. So it's important that everybody is on board in terms of that there is a benefit on this, and it's a tangible benefit, not just, you know, emissions cut by X% by 2050. So it's something that affects us, how we will change, and probably even more, just not even just the consequence of climate change, because it's becoming a little bit too much for people being repeated too much, but like, okay, my livelihood will be preserved, there will be jobs, there will be new types of jobs, etc. So also understanding the motivations of the common people is important, so that we can apply the technology and the knowledge in order to benefit them.
Fabio, you have a response, please go ahead.
Yeah, just to expand on it, on what I see is happening as a reaction of the media. I mean, every morning I punish myself by reading the newspapers in Italy, and 80% of these newspapers, that they are every day against publishing something against the new regulations for the buildings in Europe. They are saying, you know, this is going to cost us 50,000, 40,000, 25,000, but this is something that, you know, Europe is stealing from our pocket. And you understand that they are paid by somebody. That's not, it's not the journalist, it's not the writer. There are powers behind this that are pushing to slow down the process, because, you know, in Italy, we are all using gas, and we have gas in our houses. And if we are improving the efficiency, we are reducing the gas. So there is something which is, it's a big game there. And okay, we have our role, that is to develop technologies, but we have to understand that the story is it's more complex, and we are playing against interests which are vested or not vested. Sometimes they are very, very clear. But, you know, every day it's unbelievable that, you know, something that which will improve everything, including the pocket of the householders, it's described as something which is, you know, an attack to our personal finance. And I think we have to take care of this, also as scientists, because it's, I see colleagues, you know, every day they are trying to say their opinion against this. And this is very important to be in the media, to be part of the public debate. So it's a call for action in this sense. It's nice that we talk among each other, but it's even more important that this is done on a public and political level.
Yeah, so maybe Fabio can just maybe share, there's a concept in science also, we call it carbon footprint, but we have also a carbon handprint. And the handprint concept means that you need to take action in the hand. So very simplified for you, but that's what also you're calling for. So it's what you can take action in your company, in your private life, with your friends, wherever. So typically you have much more action around you. So that's again the call for the people. Salvatore, may I ask you for some additional comments, last but not least, let's say. And if there's more questions, please feel free also to put it in the chat. Salvatore.
Thank you. You have already really presented very much to the point comments, and I agree with all of those. I would like just to remind a couple of things in the process. First, there has been quite a big change in Europe that, in my opinion, is one of the big, let's say, political body that is making the more for really achieving carbon neutrality. And if we remind the recast of a PBD, basically the idea was, let's activate first the public sector and then the private. So the public would have been the driving force. Now, more recently, with the mission, actually this guiding role was moved not to the general public sector, but to individual cities as a representative of different stakeholders intertwined. And this is very interesting because in that process of changing a city, we are supporting the city of Limassol here in Cyprus, you really need to have a representative of all the stakeholders. And you understand that nothing can happen if not all the stakeholders are involved, if the infrastructure is not upgraded, if the policy is not in place, if the market is not developed, if the scientific development are not up to the standard. So we need different components, first. Second comment, we are not speaking anymore about showing the way, beacon project, pilot project. Here we are speaking about changing our lives, our city, our building stock. It's not anymore time to select stakeholders. Here is everybody that must contribute in the power that everybody has in order to change our city, to really make this transition effective. How to do this? There are some incredible opportunities, but also some problems. The financial one is important. We have started years ago to work with the financial sector, and actually was quite surprising from my side to understand how secure is energy efficiency. So while 20 years ago was something naive, now also a financial body knows that energy efficiency is true, exists, is something concrete, less volatile than crypto or other kind of thing. The issue is that maybe the system is too complicated to be, let's say, simply moved. But definitely, I think that we have to do that. It's not to choose which stakeholder to activate. It's all the stakeholders must be activated. We need to understand altogether how this has to happen.
Many thanks, Salvatore. I see Reinhard Stelzer. Do you have a question? Is it put on your camera? No, then maybe not. Any other questions from the audience to our speakers? I didn't see anyone. From you, Brigitte, or Hannah, or someone else who is still there so late in the night?
So late, well, it's not that late, come on. I mean, for some of us, it is very late. For Salvatore, for example, who is, you know, in the other time zone. But, you know, here, Central Europe, we're fine still. So thanks very much for this very exciting interaction here. Lots of aspects we've learned. Also, normal users like me, for example, we understand a bit more what can be done with new technologies also, but of course, as it was said, we all need to buy into them and make things happen together. So thanks very much for sharing this evening with us. Thank you, Alexander, also for sharing this so nicely. And we'd like to invite you also for the next lecture evening in May. That's going to be coming up soon. It's about land use. It's interesting also aspect about, you know, the different pressures that are on the land and the scarce land we have in Europe, especially. So if you're interested, please join us for that event as well. I thank everyone from my point of view. And yes, Alexander, you have to find a word, of course. So.
Yeah, also from my side, many thanks for taking the time and also to posing good questions in our discussions. I think as there was some good comments said, and I think from my personal point of view, I fully agree that it's the people whom we need to overcome these challenges. So I think we need to align the forces really to tackle this big challenge of climate change. We all know that last year was already far off what also our colleagues, the other scientists, the climate scientists predicted. So I think it's even more actions needed. And that's why it's really important also to be a voice, let's say, in our society to keep track on the transition and the path we need to pave towards a more sustainable future. So having said that, many thanks again for participating in the call, and I look forward to see you soon somewhere. Many thanks, and I think also some recordings will be then shared from this call. So if you have further questions, then you know whom to address it to. So many thanks.